Hello, everyone. Thank you for being here. My name is Naresh, and today I'll be sharing insights on how we can successfully scale AI systems in the financial industry, specifically how to handle high volume transactions while processing and while staying compliant with strict regulations. The talk will cover on operational strategies, infrastructure choices, and real world lessons we have learned from deploying ML pipelines across the financial services transaction ecosystem. The challenges that we are looking at, when we look at financial institutions, the challenges are unlike in any other industry, right? Fundamentally, we are processing billions and billions of transactions with less than a millisecond of a second response times. On top of that, every decision must satisfy the regulations like GDPR, CCPA, FCRA, and then you have to also maintain 99.99% uptime for critical systems. While achieving the uptime, latency is another aspect of it as well, right? You need to provide responses within a fraction of a second, while also making sure that the right decisions are made at the right time, the right level of compliance checks and balances happen. I'll give you an example, right? When you're doing a credit card authorization transaction, the authorization has to happen in less than like a fraction of a second because the customer is still there in the session. While the customer is still there in the session, you're engaging with the customer behind the scenes. You need to make sure the KYC is done, the KYB is done, the sanction screening check is done. So all these things have to happen simultaneously in parallel, and then a final decision has to be taken while ensuring the business outcomes are met, right? Because every drop that happens when the checkout conversion doesn't happen, that means it's a lost sale. A lost sale means it's a lost in revenue. So these are the factors that needs to be considered when we are looking at deploying machine learning systems in financial space. What are the three critical financial applications? There are three core areas. One is, as I alluded in the previous example, it is real-time fraud detection, then the credit assessment, then automated financial management of it. The first, again, I quickly touch base on this. The first is real-time fraud detection models that can scan millions of daily transactions to spot suspicious activity in milliseconds. The credit assessments, where platforms needs to evaluate the credit worthiness while remaining compliant and explainable, right? Imagine a scenario where you are applying for a personal loan or you're applying for a credit card. You would have seen this from your real world examples, like where the decision is in like few seconds. But behind the scenes, the whole aspect of assessment, prospecting, underwriting, all these things need to happen in a pretty quick time. And lastly, it is the financial management, everything from portfolio optimization to algorithmic trading to personalized financial guidance. These are mission critical, so that they rely on the strong ML operations foundations and the associated pipelines. Real-time fraud detection architecture is super important. As you can see over here on this slide, what I'm presenting over here is various channels, right? You have the transaction sources from where a transaction can originate. You have point of sale channels, you have online channels, you have mobile channels. So all these channels have their own respective streams, and those streams of data have to be processed and published. And that is where the next aspect of pipelines and feature store come into the where we outline what are the low latency inference systems, what are the decision engines, what are their rules that they're applying, and finally, monitoring and audit systems, right? Ensure telemetry, retaining, and compliance. The key point here, though, fraud detection isn't just about a model, it's about a pipeline that can handle massive scale in seconds. What are the challenges in fraud detection in MLOps? And this is another key vector that needs to be considered. And as you see on this slide, is the real-time performance. Achieving sub 10 millisecond latency while processing over 100,000 transactions per second during peak periods is incredibly demanding. Then the feature freshness, right? Fraudsters evolve quickly. The DDoS attacks that we have seen over the last few instances will actually peak, right? And that plays a critical role in ensuring that our features stay in compliant and with various fraud patterns. The third is the rapid adaptation, which is fraud tactics emerge constantly and our systems need to recognize them immediately. False positives, that's the final behavior. If we flag too many legitimate transactions, we are losing the risk of losing the customer. So that's another thing that needs to be kept in mind. And that is where the balancing act has to be super efficient. Otherwise, we run into the risk of losing valued customers, which in turn impacts sales and revenue. The next slide, as you guys can see over here, it speaks about what are the key vectors in assessing a credit application or assessing creditworthiness of an individual using the MLOps framework. As you can see, the frameworks ensure data orchestration that tracks the full lineage of every data source. Model governance provides version history, approval workflows, so we know which model made which decision. And validation systems rigorously test for fairness. When it comes to lending, regulators and customers need to know the system is both accurate and fair. That's on the credit assessment side of the world. And of course, the final aspect is the automated financial management systems. This is again super important because if you consider in any line of business, whether it is payments or lending or for that matter, any financial transaction, at the end of the day, everything has to be reconciled. It's a zero-sum principle, right? The debits and credits have to match, and you cannot have money being created on the fly, right? It cannot be created nor it cannot be destroyed. Every record has to match. And that can be achieved through streamlined model deployment pipelines, monitoring systems, integration workflows, automated workflows, where you can actually achieve this through various streaming technologies as well. As and when a transaction happens, you will publish it to a Kafka topic, consumers subscribe to the topic, and then you record the transactions in your ledger system. You use it for reconciliation, settlement, clearing, making sure that everything is reconciled behind the scenes. So it's super important to have automated financial management systems. Otherwise, it becomes super tricky to track the transactions. And the next slide, as you can see over here, it covers the high-level architecture for deploying MLOps in financial services. As you can see, at the foundation is a data infrastructure, right? Governance, processing, storage for structured and unstructured data. Need to have a set of policies for both structured and unstructured. One set of policies for structured, another set of policies for unstructured data. On top of it sits the training and validation pipeline, which automates the compliance checks, which automates the testing procedures of the same, all of the various validation pipelines, right? And then the layer, that is the engineering and storage layer that delivers both batch and real-time features, depending on where you need. And then finally, we have the model registry and deployment systems for versioning, A/B testing, and various rollouts. Right? You want to do controlled rollouts, controlled testing, where you actually decide, oh, if I pull the lever of a particular parameter in one direction, how is it going to behave, or how the impact is going to be on my core products and features? Will it improve take rate? Will it improve conversion? Will it reduce the fraud rates, or will it increase? So these are the various vectors that you can control by virtue of having versioning and A/B testing. And finally, at the very top is the model serving, which is the high performance APIs that powers customer facing applications. You need to have, as I alluded at the start, in either of the use cases where a customer is waiting on the checkout screen trying to purchase a product, or a customer waiting on the screen where they're trying to apply for a loan. These are very time sensitive customer flows. So the high performance API layer on the top ensures that the right level of information is abstracted, thereby servicing the clients in a timely manner. The next slides talks about how do we do model deployment strategies in a containerized manner. Containerization has been a game changer in this space, right? The Kubernetes size, separate clusters are there for training and inference, GPU nodes for deep learning and auto scale based on demand. Compliance critical models, you can in fact scale horizontally and vertical by having dedicated nodes or isolated nodes. Financial institutions also add domain specific optimization, hot standby replicas for zero time, geo distributed deployments. So that's super critical in terms of having your well-defined deployment strategies. And the next slide is on about real-time monitoring and alerting systems. This is where all of the key technical metrics would be like what is the latency, what is the throughput, what is your resource utilization, is it at the max resource utilization, min resource utilization, so that you can dynamically at runtime either increase the capacity or reduce the capacities. And so you can also actually track the error rates. The key other thing is the model performance, right? Predicting what is the accuracy of it. What are the drift in terms of distribution? How is that being used? And of course, pertaining to that would be the business KPIs in terms of what are the approval rates, what are false positive, how is it impacting the revenue, customer experience, and all those things. And lastly, compliance is a key aspect of it. So ensuring that the end-to-end transaction is thought through in terms of observability and reliability standpoint. And what are the various automated validation frameworks you have? You have data validation, you have model training, performance and fairness explained in the compliance side of the world. Financial institutions have to ensure that the validation processes needs to be there. Otherwise, how do you know the robustness and the accuracy of a particular model before you go ahead and deploy that in production? And thereby, you don't want to have such a scenario where you don't validate and deploy it in production, and then all of a sudden it can have negative impact across the length and breadth of the spectrum. And then the next slide is about, I would want to speak about like the model drift in high stakes environments. Like what exactly is a model drift? You just cannot avoid model drift, right? It's unavoidable especially in a high stakes environment, right? How do you detect drift? Drift through statistical tests, segment-based analysis. And whenever a drift occurs, how do you respond? You respond through shadow deployment comparison. You gradually ramp up the traffic, ramp down the traffic. And then that is where, when in doubt, you have a fallback approach of human in the loop approval, and then track the audit trail to make sure that the performance through transitions is seamless. And then I would also want to speak about implementing A/B testing for financial models. That is where A/B testing is another area which is super critical. Start with clear hypothesis tied to business metric, test designs, ensure statistical rigor, ensure carefully and control for adverse effects. Impact is analyzed at the segment level, and rollout is progressive with continuous monitoring. Yes, innovation is the key, but not at the cost of not protecting the customers, right? Safe A/B testing is super important. So to wrap up, what are my key takeaways, right? Design for scale from day one, integrate compliance through the pipeline, automate everything, but ensure the fallback mechanisms are there where human in the loop intervention is there, and then investing in robust monitoring and response systems. That's pretty much it. And I hope you were able to gather some insights on my presentation. Thank you for giving me this opportunity.